Assalamu alaikum wa rahmatullahi wa barakatuh. You are welcome to another edition of the online class. Today we are going to still continue with the periodicity of elements. If you remember, last week we were able to explain the periodic table. Today again we are still going to continue with that, where we'll be looking at each group in the periodic table. Now, what we are going to look at today is the families of this element, the periodicity of the periodic property of the element, the first transition series and their property. We are also going to look at the lanthanides and the actinides. So let's go to each group of these elements. Let's go to each group of these elements and look at their property. The first group there is group 1 element. We call them the alkali metals, and among them is lithium, sodium, potassium, etc. They are univalent metals. Yes, because they have only one electron in their outermost shell. They have only one electron in their outermost shell. And then because they are metals, they donate this electron out, and that is why their oxidation number is +1. They react violently with oxygen to produce basic oxide. As we all know, they are metals. Metals do react with oxygen to produce basic oxide, and this basic oxide, when they react with water, they liberate hydrogen gas, and then leaving the solution to become what? Alkaline. Their tetraoxosulfates and their thiazocarbonate 4 are all soluble in water. Their salts are white in color. For example, the sodium chloride, that is the salt we use in our homes, you can see that it is white in color. The next group that we are going to look at is the group 2 elements, which are known as the alkaline earth metals. Among them we have the calcium, the magnesium, and so on. They react with hot water only. Calcium reacts slowly with cold water. The reason being that if you compare the reactivity of these elements with the group 1 element, you see their reactivity is decreasing. The reason being that when you look at the activity series, at the top of the series, all those elements that are there are what? They are the most reactive, and the reactivities goes down the series like that. So as you move down the series, you see the reactivity of this metal decreases. Now we say their tetraoxosulfates and their tetraoxosulfates are insoluble in water. Their oxide and hydroxide are also weak bases. The reason is still due to their reactivity. Their thiazocarbonates are also insoluble in water. Their thiazonitrate 5 and their thiazocarbonate 4, they decompose by heat. They are decomposed by heat. For example, you look at the calcium thiazocarbonate 4. See, when it's being heated, it's going to produce what? Calcium oxide and then oxygen. The next group we are going to be looking at is the group 5 element, which comprises of nitrogen, phosphorus, and then so on like that. They exhibit the valency of +3 and +5. You all know what is valency. They exhibit very similar property, and they react with oxygen to produce acidic oxide, because what? They are non-metals, and non-metal do react with oxygen to produce acidic oxide. This acidic oxide, when they dissolve in water, when they react with water, they produce acidic solution. The next group we are going to be looking at is the group 7 element. The group 7 element. These group 7 elements, they are also known as the halogens, which are the salt formers. Among them we have the fluorine, the chlorine, and the bromine. Now, these elements, their reactivity decreases down the group. Like fluorine is more reactive than chlorine. Chlorine is more reactive than and bromine, and then their reactivity goes like that. You see, they are monovalent non-metals because they need only one electron to complete their shells. They are known as salt formers. Yes, they are known as salt formers. For example, like the sodium chloride we use in our house, whereby this group 7 element react with what the group 1 element, that is among sodium, to produce sodium chloride. Now, they show great similarities in their properties, and they are the most reactive elements. They exist as a diatomic gases. See, F2, Cl2, and so on. They are all colored. For example, iodine, the color of iodine is what? Is brown. They form covalent bond with hydrogen, like hydrogen fluoride, hydrogen chloride, and so on. They also form covalent bond with metals, like group 1 metals, group 2 metals, and example is sodium chloride, like I've said before, potassium chloride, with group 2 elements, magnesium chloride, and so on like that. And if you look at their order of reactivities there, if you look at that, you see that the fluorine is the most reactive element there. Then the least reactive there is iodine. Now, the next one we are going to be looking at is the group 8 element. Which is either we call them group 8 elements or the group 0 elements. They are the noble gases. We can call them the real gases or the inert gas due to the fact that they are not reactive. They are monoatomic molecules. They are not reactive because they have a complete valence shell. Their shell is complete. Like the helium is duplet. It has a duplet structure which is complete. It's either they have a duplet or octet structure. So their atom's electron is what is complete, and that is why they are inert. They show very similar property among themselves. Their melting point and their boiling point increases down the group, while their ionization energy decreases down the group. We are still going to talk about that. Now, let's look at the next element now. The next element there is the transition metals. That is the D block element. These elements are between the group 3 and then between group 2 and group 3. They are all metals. They have the ability to act as a catalyst. Like we have iron, nickel, and so on like that. They all act as a catalyst. They are all paramagnetic due to the presence of unpaired electron. Now, iron is ferromagnetic. Because if you look at the d orbital of iron, it has one complete d one of the orbital paired up, and that is why it is ferromagnetic. They all form complex compound. Like for example, we have sorry, I said they form complex compound. For example, we have tetraamine, cobalt, tetraamine, copper 2 ion, and so on like that. They have variable oxidation state. They have variable oxidation state. Like for example, we have the chromium 3, we have chromium 6. We also have copper 1, we have copper 2. We have iron 3, we have iron 2, and so on like that. They form colored compound. They form colored compound. Like copper 2, the color of copper is the color of colored compound of copper is blue in color. Iron 2 is green. Iron 3 is brown in color. The next one that we are going to be looking at is the inner transition element. The inner transition element, those ones at the bottom of the periodic table, where we have the lanthanides, which is the first series there, and the actinides, which is the second series. The lanthanides are the period 6 elements. They start with lanthanum and they end with lutetium. Then the second series, which has the period 7 element, among them is the uranium, which is used in the nuclear reactions. Now, any elements after this uranium are known as artificial elements. Example is plutonium, which is formed during the nuclear reaction. That is that for these for the groups in the periodic table. Now, let's look at the periodicity of some property in the periodic table. Now, the physical and the chemical property of an element depend on the electronic configuration of its atom. That is according to the periodic law. Now, any of this property of this atom that varies with electronic configuration will exhibit periodicity. Now, before we go to that, let's look at the group relationship, horizontal relationship, and the diagonal relationship. That is what we are going to be looking at now. Now, let's go back to our periodic table. The group relationship now. Among the group, if you look at group 1 element, you see that they have 1 electron in their outermost shell. They have 1 electron in their outermost shell. All of them, they have only 1 valence electron. And therefore, that is why they show similar chemical properties. That is why they show similar chemical property. The same thing applies to the group 2 elements, and it goes like that. If you look at the horizontal relationship, that is across the period, if you are moving from sodium to aluminium like that, if you are moving like that, you will see that now across the period there is a continuous variation in the electronic configuration of these elements along each of these periods, which leads to the variation in their physical and chemical property, because electrons enter into different s and p orbital. Now, when you are going from the left to right across the period, metallic characteristic decreases. The next one we are going to look at is the diagonal relationship. Look at the diagonal relationship is the relationship between the first member of group 1 and the second member of group 2. That is, lithium and magnesium has diagonal relationship. The same thing, beryllium and aluminium, they also have diagonal relationship. And boron and silicon also have diagonal relationship. Now, because their metallic characteristic decreases down the group and decreases across the period. There exists a diagonal relationship between the chemical property of the first member of group 1 of a particular group and the second member and of the next group, like that. So that is that. Now let's go back to our periodicity of elements now. Let's go back to periodicity of elements now. Now, we want to look at these important properties that show periodicity of elements. Among them is the melting and boiling point. The melting and boiling point of metallic elements increases from left to right, and those of the non-metal decreases within a group. The melting point of the melting and boiling point of metal decreases down the group, while those of the non-metal increases down the increases. Now, the electrical and thermal conductivity. These two properties, they decrease across the period. That means as you are moving from left to right, and increases down the group. Now, the next one we are going to be looking at now is the atomic radius. Atomic radius, which is the distance, which is the half distance of the closest approach between the nuclei of two adjacent atoms. If you look at this my diagram, from the center of this particular atom to another one which is adjacent to it, to the middle of it, is what is known as the atomic radius. Now, this atomic radius depends on the atomic size, and also the atomic volume also depends on the atomic size. Both of them, and both of these, they follow the same trend. These three follow the same trend. Now, what is atomic volume? The atomic volume of an element is the relative mass per unit density. It is the relative mass per unit density. Now, this atomic radius, now we say it decreases across the period. It decreases across the period. Now, the reason being because as we are moving from left to right across the period, this property decreases because the electron that are being added, they are added to the same outer shell. Therefore, the outermost electron are drawn close to the nucleus, and when they are drawn close to the nucleus, the size of this particular atom decreases. The size of the particular atom decreases. Now, we say it increases down the group. That means from what? From the top to the bottom. Now, the reason is because as we go down the group, the number of shell increases. Since this number of shell increases, then the distance between the valence shell, that is the outer shell, and the nucleus, they are what? They are far apart, and the repulsion between them is greater. The repulsion between them is what? Is greater, and that is known as the shielding effect. That is known as the shielding effect. Now, so the reason for the decrease across the period is what is known as the nuclear charge. Now, what is the nuclear charge? The nuclear charge is the number of protons in the nucleus of an atom. Now, while the screening or the shielding effect is the effect which is due to the repulsive force between the electron in the inner shell and those in the outer shell. So as this shading effect increases as a result of increase in the number of shell, the repulsion also increases, and also the size will increase. So that is that on that. Now these are the two factors that which I've just explained. Now let's look at the ionic radius. Ionic radius, which is the what? Which is the half distance between the nuclei of two adjacent atoms of the same element. Now we say the ionic radii of positive ion are smaller than that of the corresponding atomic radii, and vice versa. Now, the factors that determines atomic radius. Number one is the number of electronic shell. Number of electronic shell. Now, for example, let's look at sodium. Sodium now has 281, that is 3 shell. Now, if sodium atom forms an ion as a result of loss of 1 electron, the shell will what? Will be reduced to 2. The shell will be reduced to 2. And when the shell reduces, the distance from the nucleus will also reduce. The distance of the distance of that the valence shell and the nucleus will reduce. So the next one, let's look at the effective nuclear charge. The effective nuclear charge, which is the difference between the number of proton, the difference between the number of proton and the number of proton and the number of electron in a, and the number of electron. Sorry, we are talking about the effective nuclear charge, which is what? Which is the difference between the number of proton and the electron in an ion. Now, I will still talk about that again. When an atom loses one or more electron, there is an increase in the effective nuclear charge, and that is more proton. There will be more proton than electron, and the excess proton will draw the remaining electron closer, so the ionic size will be reduced. The same thing for an ion. An ion will add more electron. If it has more electron, or that is if it's gain more electron, there will be decrease in the effective nuclear charge, because the attraction to the nucleus will be less, and the distance between the nucleus and the outer electron and the outer shell will be large. So an ion radius will be greater than the corresponding atomic radii. The next one that we are going to be looking at is the ionization energy. Ionization energy is the energy that is required to remove the most loosely bound electron, to remove the most loosely bound electron from the outermost shell of an atom. That is ionization energy. Now, this ionization energy, we say the trend, it increases across the period. It increases across the period. That means as we move from left to right, the ionization energy increases. Now, the reason is because along the period, there is an increase in nuclear charge and decrease in atomic size. Now, the electron to be removed, therefore, is closer to the nucleus, and so the attraction is what? Is very strong. And then the ionization energy will what? That means the energy that you have to apply to remove this electron, it will be greater. Now we say it decreases down the group. The reason is just because of the screening effect of the inner electron, because more electron, as you go down the group, more electron is being added, and if more electron is added, the repulsion between them is what? Is greater, and then the energy in which we are going to use to remove this electron will be smaller. The energy we are going to use will be smaller. Now we say the first ionization energy. The first ionization energy, which is the energy that is required to remove the outermost electron in an atom in gaseous state. Now let's take a look at for example, let's take a look at sodium again. Sodium has 3 shells. That means 2H1. If you look at the distance of the nucleus to the third shell, is what? Is a little bit far compared to the second shell. By the time the first electron is being removed, the energy to which we will apply will be small, because the distance is what? Is a little bit far than when we want to remove the second electron. If we want to remove the second electron now, the distance is close to the nucleus, and then there is what? The repulsion will be less. The repulsion will be less as a reduction in the as a result of the reduction in the shell, and so you have to apply more energy, and that is why the first ionization energy is always less than the next ionization energy. The next one we are going to be looking at now is the electron affinity. The electron affinity is the energy change that occurs when an isolated gaseous atom acquire an electron to form an ion. Sorry, before I move on with that, let me still say something about this ionization energy again. If you look at the ionization energy here, one electron is being removed. If you look at the arrow, it's showing how the ionization takes place here, where one of the electron is being the electron of S is being removed to form an ion. Now that is the one I didn't show you. If you look at the reaction very well, it is different from that of the electron affinity. Now this ionization energy, the process is endothermic. So let's move back to the the electron affinity now, which I've said before is the energy change that occurs when an isolated gaseous atom acquire an electron to form an ion. Now if you look at this reaction very well, you see that it is the opposite. Here is what is receiving an electron to become an ion there. Now we say the trend, the electron affinity is what? Is an exothermic process, and that is why we say they are opposite each other. Now if you look at it, it increases across the period. Due to the what? Due to the increase in the atomic size. It increases across the period. I say due to the what? Due to the increase in atomic size, while it decreases down the group, which is due to the increase in the it decreases down the group due to the increase in atomic size. Okay, please let me repeat myself. I said it increases across the period due to the decrease in atomic size. It is due to the decrease in atomic size, as we all know, due to the nuclear charge. So that energy will be greater. We know what is nuclear charge. There will be great attraction between the nucleus and the electron. So it will decrease, the electron affinity increases across the period due to the decrease in atomic size. Please, sorry for that mistake. Now it decreases down the group. The reason is because of this shielding effect, because the atomic size increases due to the increase in the number of shell. Now the last one which we are going to talk about is the electronegativity, which is the power of an atom in a molecule to attract electron to itself. All of them have the same reason, which is due to the nuclear charge and the screening effect. Now let's look at the trend. We said it increases across the period due to the decreasing in the distance between the valence electron and the nucleus. That is the nuclear charge. And then it decreases down the group. Also, it's still due to the number of electronic shell, because as we go down the group, the number of shell increases, and then the repulsion between them will increase. Now the next thing we are going to be looking at is the questions, the examples that we have stated. Now one of these is state the importance of electronic configuration. State the importance of electronic configuration. State the importance of the electronic configuration. The importance of the electronic configuration, the importance of electronic configuration is that it determines the physical and the chemical property of an element. That is that for that question. Now question 2, explain why the atomic size of oxygen atom is smaller than that of boron. If you look at the electronic configuration of boron and oxygen, you see that for boron is 2,3, while for oxygen is 2,6. Now both of them, they are in the same period. Because they have 2 shells. Now they have two shells, but the nuclear charge of oxygen is larger than that of the boron, because electron in the oxygen atom are drawn close, because it has because the electron are drawn to the nucleus in oxygen. That means there is a great attraction to the nucleus in oxygen than in boron, and that is why the atomic size of oxygen is smaller than that of boron, due to the attraction. The attraction is boron is less than that of the oxygen. So the atomic size of oxygen is smaller than that of the boron. That is that. Now example 3. Explain why the atomic size of oxygen is smaller than the ionic size of its anion. The reason being that the anion of oxygen has accepted 2 more electrons, and this electron is added to the what, to the outermost shell. So there will be less nuclear charge in the anion than in the corresponding oxygen. Now another reason again is the shielding effect. So there will be great repulsion between the inner electron and the outer electron. So it is due to this the repulsion as a result of the added electron. That is why, and then as a result of the added electron, which leads to less attraction because of this added electron by the nucleus. There is a less attraction to the nucleus due to the added electron, and therefore the atomic size of this ion will increase. Now the last question for today, we say X, Y and Z are metals in the same group in the periodic table, but in period 3, 4 and 5 respectively. Which of them loses electron least and why? That means which of them will lose electron least and why. Now the solution, if you look at them, all of them, they are in the same group. That means they have the same valence electron, but their periods are different. That means S being in period 3 has 3 shells, Y being in period 4 has 4 shells, and Z being in period 5 has 5 shells. If you look at their distance, the distance of the valence shell to the nucleus, the distance of S to the nucleus is what? Is small compared to X and Y, and so there is great attraction to the nucleus in S than in Y and Z because of the electron, the shells. So it is the distance. So it will be easier to remove electron. It is be easier for Z and Y to lose electron than S, because S has what? S has great attraction or more attraction to the nucleus than Y and Z. So S will require more energy than Y and Z. So that's the assignment is 1. Briefly explain the property of the following group 3, 4 and 6, and then the second one is to differentiate between ionization energy and electron affinity. So this is where we are going to stop for today until we meet in another episode of this online class. Assalamu alaikum wa rahmatullahi wa barakatuh.